sorry about that. This was my original project. In the end, I didn't spend as much time as I would have liked to have done on this, just because I got caught up with the vaccinations and so on and so forth. But it was still very interesting, and I think some good learning points for me from it. And I certainly plan to try and take it further forward in my own time from now. So I'll share my screen now. I'm hoping that's the big screen. So can you see my notes down the side, or is that the slideshow version?
No, that's the slideshow version we've got.
Great. So the idea was to try and predict who's going to get admitted to hospital, and using GP notes, and thereby, if we can successfully predict people who are likely to get admitted, try to proactively prevent that, and thereby improving their health and saving the significant cost of admission to the NHS. Okay, so who were the team? So I had lots of help from Imca Pelling from RD&E, Mona Nasser from Plymouth Uni, and then me. So a bit of background. Todd Chennell from Devon CCG has looked at something similar before and worked up something called the Devon Predictive Model, which looks at some very basic information from GP notes, but it's more sort of hospital notes based, and use a logistic regression method to try and see who's likely to be admitted. And it found that by far the biggest predictors of admission were age, unsurprisingly, and a recent admission made it much more likely to be readmitted. So we're going to use a kind of two-pronged attack, use natural language processing to try and delve into the free text in GP notes to see if there's any information that would be useful that we could glean from that, and machine learning techniques to try and to get some predictions. So I split. I used the notes from my surgery here at Northern. We've got almost 13,000 patients, and as a training set, used patients over 18 who were at the practice from the 1st of January 2018 to 2019, and who were still alive at the start of 2019, and then looked at which of those patients were then subsequently admitted over the next 3 months. And then we were planning on testing the model on the same group of patients, but a year later. So not exactly the same group of patients, but the same criteria of patients. So those who were over 18 on the 1st of January 2019 and still alive on the 1st of January 2020, and then trying to predict those who were admitted in the subsequent 3 months. So lots of problems along the way, and the initial problems were data cleansing. So just finding out which patients were admitted, which was rather important to the project, proved to be quite difficult. And believe it or not, there's no consistent record in GP notes about which of our patients have been admitted and when. We get discharge summaries, which are coded into the notes when a patient has been discharged. But of course, that's not at the same time as an admission, and not everybody who's admitted then subsequently gets discharged. So that was a bit of an issue, and the data for that had to be sourced from North Devon District Hospital. But that included all patients who came through A&E, and even those who attended by minor illness and then went home. And so that took quite a lot of work, just trying to work out which of our patients at Northern were admitted and when. And of course, it doesn't include patients who were admitted to other hospitals. I mean, the vast majority get admitted through North Devon District Hospital, but not all of them. So having got the initial data relatively cleansed, we then had a look at the natural language processing part of it. So using a Python resource called SciSpacey, we tried to look at the free text in GP notes to see, just to get a feeling of what kind of stuff we could draw out of the free text. Again, there were difficulties along the way. Actually extracting the data from GP notes, the free text from GP notes, into a format that we could then use SciSpacey on proved difficult. And initially, I had to go through individual patients' records, cutting and pasting onto Word, and then using that. And that's obviously not scalable. I did find a slightly easier way to do it, but not significantly easier. Then there was the problem of data anonymization, and so both Imca and Mona, neither of whom worked with northern surgery, and therefore we had to be very careful about data protection. And so then I had to go through each patient's notes and try and remove any identifiable data. In fact, I think if I was going to go on with this, then I'd like a natural language processing program to try and pick those bits of information out of the patient's notes to remove them automatically. But that's something for the future. Inevitably, there's lots of irrelevant information that gets picked up by SciSpacey. And it turns out that not only do GPs have terrible handwriting, but we're also appalling at spelling. And so there were lots and lots of spelling mistakes, which makes the data more inconsistent. There's also inconsistent extraction of phrases from the free text. So, for example, someone might have written "no improvement in pain," and on some occasions that would be interpreted as just pain or in pain. Other times it could be improvement in pain, and other times no improvement in pain. All three things obviously move quite significantly different things, and one would imagine would affect the likelihood of omission differently depending on interpretation. So again, using SciSpacey, we extracted these named entities from 10 patients' notes who were admitted and 10 patients' notes who weren't admitted. And then we compared the frequency of these named entities. And probably the most striking thing was the pure volume of named entities that were extracted from patients who were admitted. There were far more than those who weren't admitted. And certainly from those very initial results, there seemed to be some named entities that were more frequent in the admitted group to the non-admitted group. And I think pain was the one that stood out the most. That's as far as we got with that branch of the project. I think the next steps really need a far greater volume of notes to be able to draw any significant conclusions. And so I need to try and work on how I can ease that process of getting the notes in a readable form. Having done that, it would be good then to possibly use the occurrence or the number of occurrences of various named entities as inputs into a neural network, or feed it into logistic regression to then try and predict omission from those. And also just having some measure the pure volume of notes as an input. The next part of the project was a more traditional, I guess, and close to the Devon predicted model. And this gathered a data set of all patients, including whether they'd been admitted or not, and the age and list of chronic diseases. There were quite a few new things that hadn't been checked in there, like their frailty index, the number of medications they use, the number of GP appointments, etc. And then having all that data and information, I then ran an initial logistic regression to try and see if there's anything that came out from that. And it was amazing. I was so excited, 95% accuracy. Now, I had been warned about this, and unfortunately, looking closer into it, it had 0% sensitivity. So what does that mean? Well, what it meant is that because admissions are such a rare event, I think 4% were admitted over that period, that the model achieved amazing accuracy by predicting that no one was ever admitted. It, while having a very impressive looking accuracy, it was entirely useless because it was unable to or didn't predict a single admission. In fact, I think it predicted about 3 and it got those wrong. So that wasn't encouraging. So again, that's as far as I got with this. But what I did start looking into and getting advice as to what one can do about that, and what the next steps would probably be is, rather than just outputting whether someone was admitted or not, would be actually output a probability of admission. And then one could adjust the cutoff for saying whether someone was predicted to be admitted. You could adjust the probability that was needed to predict that, so that the number of predicted admissions were much closer to those that are expected. There are other techniques that you can use, like undersampling the majority class, i.e. those not admitted, or oversampling the minority class. And also, there are techniques to create synthetic data to balance the two classes. So, in summary, the data extraction did prove a major obstacle, particularly for the natural language processing. But I think there are interesting possibilities for using this if this obstacle could be overcome. Another learning point for me was the difficulty in training a model to predict rare events, though there are techniques that could help.